We now discuss the solution of a problem from the section Differential Calculus. This question is related to the differentiability of a given function. This question has appeared in the joint entrance examination main held on 6th April 2023 in the first shift. The given question is, let a be an integer and bracket t be the greatest integer less than or equal to t. Then the number of points where the function f of x is equal to bracket of a plus 13 sin x bracket close, where x belongs to the open interval 0 to pi, is not differentiable is. We are given a is an integer, bracket t denotes the greatest integer function of t. Required to find the number of points where this given function f of x is equal to bracket of a plus 13 sin x, where x belongs to 0 to pi, is not differentiable. We now discuss the solution of the problem in detail. We have a is an integer and bracket t is the greatest integer function of t. Let's recall the properties of bracket t. It is known that bracket t is not differentiable when t is an integer. What happens when t is an integer? Bracket t will be discontinuous there. When it is discontinuous, it is not differentiable. So, we know this. Bracket t is not differentiable when t is an integer because bracket t is discontinuous at these points. And bracket t is a step function. Right. Now, f of x is equal to bracket of a plus 13 sin x, where x belongs to 0 to pi. What is a? A is an integer. Let us recall a property of bracket functions. So, bracket of x plus n, where x is any real number and n is any integer, then bracket of x plus n is equal to bracket x plus n. This is true for all x belongs to the set of real numbers and for all n belongs to z, the set of integers. So apply here. So that's equal to a plus bracket of 13 sin x, x belongs to 0 to pi. Now suppose you take this function. Now a is a constant because a is an integer, a is a constant. So where f of x, if you want to discuss the differentiability of f of x, you discuss the differentiability of bracket 13 sin x, because a is an integer which is a constant, is differentiable everywhere. So the number of points where the function is not differentiable is equal to the number of points where the function bracket 13 sin x is not differentiable. That means it is not differentiable if it is discontinuous at 0 to pi. So the number of points where this given function f of x is not differentiable is equal to the number of points where the bracket 13 sin x is discontinuous in 0 to pi. When this is discontinuous? When 13 sin x takes integer values. So that means the number of points where 13 sin x is an integer in the interval 0 to pi. So you have to count the number of points where 13 sin x takes an integer value in the interval 0 to pi. Agreed. So now note that 13 sin x takes values between in the interval 0 to 13, open at 0 and closed at 13 end. Why? See, sin x varies from 0 to 1. But x belongs to open interval 0 to pi. Therefore, sin x 0 is excluded. So 0 less than 13 sin x is less than or equal to 13 because x is equal to pi by 2 is included here. And you see this is because up to 0 to pi by 2, and it repeats again pi by 2 to pi because it is symmetric. Sin x is symmetric about the line x is equal to pi by 2. So whatever happens in 0 to pi by 2, the same thing happens from pi by 2 to pi also. So now for this, let us take alpha, an integer, where alpha takes the values from 1 to 12. So it's a positive integer. Alpha is 1, 2, 3 up to 12. Because 13 sin x takes values between 0 to 13. So you are considering 13 sin x when it takes the value of 1, 2, 3 up to 12. Of course, it takes 13 also at x is equal to 0 to pi by 2. X is equal to pi by 2. Agreed. Notice that if 13 sin x is equal to alpha, where alpha is any value between 1 to 12, then 13 times sine of pi minus x, so is equal to 13 into sine of pi minus x is also sine x. So 13 sin x is equal to alpha. That means if 13 sin x takes a value alpha, then 13 sin x also takes a value alpha for pi minus x. So 13 sin x is equal to alpha for some x, then 13 sine of pi minus x is also alpha. So now 13 sin x is equal to alpha for x, and it is also for pi minus x, because you have seen above, where x will be what? 13 sin x is equal to alpha means sin x is equal to alpha by 13. That means x is equal to sin inverse alpha by 13, which belongs to 0 to pi by 2. So what do you observe? What do you observe? So you will see 12 points, that is x, 12 x's, such that 13 sin x is equal to alpha, and 12 points they are pi minus x in the interval pi by 2 to pi. So in total you are getting 12 before pi by 2 and 12 after pi by 2 up to pi. So in total you are getting 24 points at which 13 sin x takes integer values. So this is what we have done. Agreed. That means for each alpha, for each integer, positive integer 1 to 12, we have two values. One is x and the other is pi minus x in 0 to pi, such that 13 sin x is equal to 13 times sine of pi minus x is equal to alpha, where x is equal to sine inverse alpha by 13, which belongs to 0 to pi by 2. So you get 12 in 0 to pi by 12 values in 0 to pi by 2 and 12 values in pi by 2 to pi, where 13 sin x is equal to alpha. So further, at x is equal to pi by 2, 13 sin x is equal to 13. So how many integer values it is taking? It is taking 1 to 12 for x and pi minus x, where x is sine inverse alpha by 13, where alpha is 0, 1, 2, 3 up to 12. So 13 sin x is an integer. What kind of integer? 1, 2, 3 up to 12 at points sine inverse alpha by 13 and pi minus sine inverse alpha by 13, where alpha is 1, 2, 3 up to 12. So these are 12 in number, these are 12 in number, and pi by 2. At pi by 2 it takes 13. So this will imply that is equal to the number of points where the function fx, which is bracket of a plus 13 sin x, is not differentiable, is equal to the number of points at which bracket 13 sin x is discontinuous, that is equal to the number of points where 13 sin x takes integer values. They are 12 in 0 to pi by 2, 12 in pi by 2 to pi, and 1, that is x is equal to pi by 2. In total, you have 25. So, at 25 points, the function bracket 13 sin x takes integer values. When it takes integer values, it becomes discontinuous. When it is discontinuous, it is not differentiable. It is not differentiable. Therefore, the total number of points where f of x is not differentiable is given by 25. So, it's a numerical type question, and the answer for this question is 25. That is the detailed discussion of the solution of the problem from the section Differential Calculus, where you are asked to find the number of points at which the differentiability is lost for a given function which involves a bracket function. And it is definitely not an easy question. It is a moderately difficult question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.